Okay, so I'm going to talk today about data types. Um, Several different types of data types, but first of all, um, I will we will talk about what a data type is, right? So data types define the way you use storage, aka memory. So, oops, memory. So in programs you write, by specifying a specific data type, you tell the compiler how to create a specific or particular piece of storage, and also how to manipulate that storage. So two things: how to create and manipulate. Um, so yeah, that's basically what a data type is. It's just memory that allows you to create a piece of storage and manipulate it. So in this memory, you could put different things. For example, you could put a different type. Um, so you could put a type. So what different types of types are there? We could say, for example, integral types. So what is an integral type? An integral type is one which has only integers, meaning whole numbers. So I guess the juxtaposition to this would be, I don't know, a float. So, I'm sorry, a float. So what would a float? Float is like the juxtaposition of an integral. So the purpose of floating point types is to represent non-integers as well. So a float is not an integral type, right? So we could start going into other things, like, for example, I don't know, primitive data types. So what is a primitive data type? Primitive data type is kind of how the name says. It's the data types that are primitive. Examples of this could be the integer, the char, the bool, the float. These are all fundamental data types that are defined within the program. So I guess the juxtaposition to a primitive data type might be an abstract or user defined data type. So these are basically data types that are defined by the user, and it's kind of the beauty of C++, that it's a wild, wild west and it lets you define whatever you want. So an abstract or user-defined data types. So these data types are like for example, defining a class or a structure. So you define your entire data type, and you get to say what member variables it has, what functions it has, what constructor, destructor it has. We'll obviously get to those keywords soon. So another important word to know is a specifier. And these words are simple, but when you talk about code and you're able to use these words, it just broadens your horizon greatly. So a specifier basically modifies the meanings of the basic built-in types and expands them to a much larger set. So it takes, for example, the primitive data types, and it might expand what they mean. So there are four different types of specifiers. So there's four of these. So one might be a long, another one might be a short, one might be assigned, and another one might be an unsigned. So I guess the best place to start would be with a short and the long specifier. Not the short long, but the short, comma, different thing, the long specifier. So the short and the long specifier, so these modify the maximum and minimum values that a data type will hold. So they modify the max and the min that a data type will hold. So a plain int must be at least the size of a short, right? And the size hierarchy for integral types is, so there's a size hierarchy of how these integral types that I explained earlier are defined and how big they are. So the size type would be, the hierarchy would be short would be the longest, short would be the shortest, for example, a short int, and then we would have an int, and then we would have a long int. So this will be like the hierarchy of the shortest amount of bits / bytes that a data type would have, as opposed to a larger long that one might have. All of the sizes could conceivably be the same, right? Because that would fit the specifications, though that's not, I've never seen that. But as long as they specify the minimum maximum value requirements on a machine with a 64-bit word. For instance, a data type might be 60, for example, like data types might be 64 bits or 8 bits or 16 bits, whatever. So these, specifiers simply tell you what the shortest and the longest type is on your system. So the size hierarchy for floating point number specifiers would be, so now we're out of ints and shorts and what we've been talking so far. And if we start talking about the size hierarchy for floating point number specifiers, then we would say a float is the smallest, then a double, then you put commas in between so you know that they're not combined. Float, a double, and a long double. So notice that I didn't put long float, right? Because that's not a legal type. There are no short floating point numbers, all right? So these would be the size hierarchy for the floating point number specifiers. And then we have, obviously, the signed and unsigned specifiers. So what are these? So these basically, they tell the compiler how to use a signed bit with an integral type, with integral types and characters, right? So floating type numbers will always contain a sign. So an unsigned number, for example, does not keep track of the sign and thus has an extra bit available, so it could store positive numbers twice as large as the positive numbers that could be stored with an assigned number, right? So an unsigned number could be bigger. So unsigned just basically means that you will not necessarily have negatives. It just goes on forever, whereas assigned, you can have negatives and positive. But since an unsigned has that extra bit that it doesn't have to delegate towards making it positive or negative, it could be a lot larger. So yeah, this is a good introduction, and I'll leave this video here and pick up next time.